Welcome to a UBTECH webinar. We're going to go ahead and get started. Really excited to have everybody on board. So before we get started, I just want to remind everyone, if you have access to a piece of paper and a pencil, that'd be great because we're going to do a little bit of robot designing and prototyping during this meeting. So if you have a second, if you want to grab, go for it. Otherwise, you guys can always, design afterwards, but it might help you guys to do that. So great. So we're going to go ahead and get started. So first, welcome everybody. My name is Rusty Nye. So I'm an implementation manager for UBTECH Education. And so if you are not familiar with UBTECH, UBTECH is the company behind a lot of the robots that you can see on the screen. So we make robots for businesses, we make robots for home, and we also make robots for the classroom, which is super exciting. And we are here today to talk with one of our robot designers. So without further ado, I'd like to introduce you guys to Robert. So Robert, hi, if you want to say hello.
Hi everyone, my name's Robert. How are you guys doing today? I've been working for UBTECH since 2016 as product developer, and I developed a few products you guys might have heard of, from like BuilderBot, MeBot 2 to FireBot, and I'm very excited to be here today with you guys.
Yeah, great. Yeah, thanks for joining, Robert. So during this session today, we're going to dive into Robert's design process, and hopefully you guys will be able to start designing your own robot at home. So our agenda today is, first we want to think about what is a robot? How can we define a robot? Then we want to look at a little bit of the robot designing process. And then you guys are going to dive into your own robot design, and you're going to start the UBTECH Design Challenge. Does that sound fun? Robert, does that sound fun?
It sounds super fun for me. I've been doing this a lot. Sometimes just for fun, just build something, just like a lot of pet projects of mine are, went through these processes.
Great, awesome. So the first things first, let's talk about defining a robot. So Robert, maybe you can help enlighten us a little bit. What is a robot?
So a robot is a combination between sensors, main control box, and servo motors. So sensors will gather information, it will detect what's in the environment, but the sensors themselves, they don't know what to do with this information. They'll put this information to the main control box, and main control box will think what to do, think about what to do. And by thinking, I mean like how you program these main control boxes. So the main control box will follow your instruction and then determine what to do. And to execute the command, main control box will transmit the information, the commands, to the servo and other motors to execute the action you wanted.
Cool. So Robert, we can think about main control boxes as the computer of the robot, or the brain of the robot. Is that right?
Yes, that's the brain, and then sensor, you can think about it as the robot's eyes and ears, and then servo is your joints, or it's your hands.
Oh, that's super cool. So I like thinking about robots this way, and we can kind of make this comparison to people because we all have sensors, on our bodies. So just like a robot can utilize an IR sensor to detect distance, people can utilize their eyes to try to see things. And, then we can, make sense of what we see by using our brain. And then we can act, by, utilizing our hands or, talking. So that's really cool. So thanks for that brief definition, Robert. And I think you had a quick video that you wanted to share. Can you highlight what we're going to look at here?
Yeah, definitely. So this video was shot in early 2017, the early development stage of BuilderBot. So back then we just like put together like a quick prototype to decide if the call function is doable or not with our JIMU servo. And then the result, it's pretty interesting. It's pretty cool. And as you can see in the video. Hey, Rusty, can you play the video?
Yeah, you got it.
Yeah, so as you can see, we use infrared sensor to trigger the robot's movement. And the robot now is constantly searching for an object. And once you find it, the main control box will tell the servo to, hey, pick the box up and move to the next location.
Oh, that's super cool. And so, Robert, you designed this robot?
Yeah, so it was at night. As you can see, it's like super dark. I was just sitting in the office, like, let's test this real quick. And I'm glad I recorded the video back then, so now we'll be able to see what was happening back then at UBTECH. Yeah.
Right. And maybe you could enlighten us. What sensors is this robot utilizing?
Yeah.
Whoops, let me back up because that was super cool.
So first, I was like, it definitely needs some kind of like a rangefinder. So IR sensor naturally is a good choice for these type of tasks. So I was like, okay, let's put an IR sensor on it. But then if you put the sensor too high, you won't be able to detect small objects. So we decided to put the sensor at the bottom, so the robot will be able to see most of the things. But one tricky thing is about infrared sensor. You can't put it too low. It will constantly see the ground, and then the sensor will lose function as well. So you have to make sure it's at the right height, but not too tall, not too high, not too tall. Yeah, not at tall position or high position.
And Robert, for those that may not know what an IR sensor is, can you tell us what that kind of sensor is?
IR sensor is basically, you can think of it. It reads the infrared. It reads the distance between your robot and the object by detecting the heat that the object is emitting.
Oh, cool. That seems pretty complex. Awesome. Thanks, Robert. So awesome. So now we kind of want to transition and think about the process of designing a robot. And all of you guys at home paying attention, this is the process that we're going to do for you guys to start building your robot to complete your challenge. So, just like all different processes, the scientific method, or the engineering design process, there's particular steps that scientists and engineers like to use to be able to come up with something. So maybe I can ask you, Robert, how do you go about designing a robot?
Yeah, so to approach, let's say JIMU robot design or just like design in general. So first you have to think about what are the tasks, like this project you wanted to help human with. So first, what are the tasks you want to accomplish? And then second, it's you plan. You start planning. How are you going to make a robot to help out with those tasks? So by planning, you have to think about what are the sensors you're going to use, sensor placement, and what motors you're going to use, things like that. And after you plan out your robot, you can start designing, building, and just iterating your robot.
Very cool. So keep that in mind, guys, because we're gonna dive a little bit deeper into that robot design process. But now I want you guys all to listen to our UBTECH challenge. So we have a challenge for all of you young inventors and old inventors as well out there. We challenge you to create a prototype. So a prototype can be a sketch or an actual robot or something that you plan to build. So prototype a robot that meets this task. It helps limit the human contact between patients and doctors. So what we mean by that is we want you to create a robot that's going to help act in between doctors and patients. Because we know, we're living in a tough time, and doctors are, really stressed to really help patients. And we want to develop some sort of robot or a prototype for a robot that helps in these situations. So a constraint for you guys to think about when you're creating your prototype is you can use pieces from your JIMU robot. If you have pieces around, or you can use parts from your U kits. So these are two, UBTECH robotic kits, or you can even just use household project or household objects you have lying around the house. So maybe you have, some craft materials or popsicle sticks, and you want to create your prototype out of that. Or if you don't have access to any of that, you can even just create a drawing or a sketch of your prototype, what you'd really like to build. So as you can see, that there aren't many constraints. We want you guys to be really creative with how you come up with this prototype. You can be as creative as possible. We don't want you to limit anything. But this is your task. I'm going to repeat myself. So your UBTECH challenge: create a prototype of a robot that helps limit the contact between patients and doctors. Does that sound cool? Okay.
Yeah, very cool.
Cool. So Robert has actually done a little bit of help for you guys to start, thinking through this process. So he's going to help lead you guys through a little bit of what to think about when you're creating this prototype. So let's go ahead and, ask him. So if you guys remember Robert's, robot design process, his first step was to try to think and try to research. So to get some, framework of what you're trying to build for. And he has actually defined or he has noticed 4 different areas for you guys to think about. So Robert, I'll let you expand on, what your thoughts are here.
Awesome. Thanks, Rusty. So step 1, right, as you guys remember, is the what are the tasks you guys want to develop today to help human or help doctors and nurses in the hospital, right? So these are the 4 type of robot that I think may be super helpful to limit human contact between caretakers and the patients. So the first type is exoskeleton. It's also called a soft wearable robot for people to wear to help people to walk again. And this type of robot has like complex sensors, like pressure sensors at the bottom, gyro sensor all around. So a robot will know what's your position, and then it will be able to help you to bend your knees or move your ankles, things like that. And this will be.
And Robert, sorry, I hate to bug you there, but I remember we were talking about this. You mentioned, Rusty, it's exoskeletons pretty much like Iron Man, which I thought that was a super cool way to think about it. So yeah, sorry to interrupt, but I thought that was so cool.
Yeah, it's super quick. You can develop like Iron Man pants, and then you can help people walk around again. Just like paint the device red and yellow, and then there you go. And then the second one is a fairly straightforward delivery robot. So as you can see in the picture, that's a concept that FedEx has. So in the white box, you'll be able to put your package in, and then the robot will drive up to your doorstep, which is pretty cool. So I just put it on there. And then I think a delivery robot can be very helpful in a hospital setting as well. And then number 3, monitoring robot. So this type of robot, it doesn't really need like a shell. It doesn't really need a physical appearance. You can think of it as a wearable technology. So you can have, let's say, a wristband or a watch type of device connect to your wrist. It'll detect your heart rate and maybe blood pressure. And then you have another device that goes onto your finger. And then that device will detect blood oxygen level, which is very useful for us today, since what's happening in the hospital. And then these devices will connect through either Wi-Fi or Bluetooth. It will connect to a nurse's station. So that nurse, him or her will be able to monitor 20 or 30 patients at a time of their like blood oxygen level, of their heart rate, to make sure everyone's safe. And lastly, it's a disinfectant robot. So this is basically a robot vacuum, but it uses UV light to disinfect the hospital. We'll drive around, turn on the UV light, kill all the germs, and go to the next location and do the same thing. Yeah.
Cool. That's great, Robert. So as you guys can see, Robert's first step in, creating a robot would be to start researching, what other robots are out there. And as you can see, Robert was able to see that there are quite a few robots that are actually working out in hospitals, which is super fascinating. I didn't know there were some of these robots that were in hospitals, and I think especially like the monitoring and disinfecting robot, that's just super cool. Um,
I can find out a lot of information. Google everything. Yeah.
yeah. Great. And so, if you guys remember, the second step in this robot design process is to start to create your plan. So maybe you've been able to identify, some other robots, that can act as inspiration. So now it's really to start, creating your plan. So Robert, do you want to expand a little bit here about how you would create your plan, and what are some things to think about?
Definitely. So it depends on what type of robot you decided to pursue, you decided to design. So first you have to think about what type of sensor your robot might need. Does it need infrared? Does it need sonar? Does it need a camera? How many sensors do you need? What are the sensor placement? If you decide to use multiple sensors. So, and secondly, of course, you have to think about how big or how small your robot has to be. Let's say if your robot has to reach like a higher shelf, so it has to have like a certain height, right? It can't be just like too short. You won't be able to do anything. And then third, color. So since we're doing a robot for a hospital setting, all the devices in the hospital are usually just white because psychologically white implies it is a clean machine, it is a clean surface. So that's why when you go to like a hotel, all the bed sheets are white because it's implied, oh, this bed sheets are clean, this is a clean surface, you can use it, and then you don't have to worry about like germs and stuff. So same thing with our robot. Maybe for hospital, white is a good way to go. And then costs, of course, your robot can't be just like super expensive, like $1 million a unit. Not that many hospitals able to buy a robot from you. So the cost has to be within certain reasonable range so that it can help the most amount of people. And then training, of course, your robot has to be fairly easy to use. You can't design a robot that require like 2-year degree to operate that robot. So it has to be maybe like a 2-day training, and any nurse, any doctor, any caretaker will be able to use your robot effectively. And lastly, function. So whatever function your robot has, it has to be able to execute correctly. Let's say most of the time, and then it only fail 1 out of 10,000, something like that. Yeah. So it has to be fairly dependent on trying to get it. Yeah.
Yeah, Robert, that's super cool to think about your planning process. So kind of what I'm thinking about is, you have to think about, what do you want your robot to do first? You have the idea. You want to create this robot that's able to help in between patients and doctors. So what you want it to kind of do, but it can do anything within that. We've identified 4 different types of robots that are working in that space. And then from there, you want to start looking at what kind of sensors does it need? What is it? How is it going to interact with the environment? How big is it going to be? What color is it going to be? I think cost is a big one because like Robert said, if it's $1 million, then probably not a lot of hospitals are going to be able to buy it. How easy is it going to be able to utilize? We need people to start utilizing these robots really quickly, so it should be pretty easy to use. And really, what is its function? What is it going to do in this hospital? How is it going to operate? So these are all really cool questions. Robert, are these like the same questions you ask yourself when you're developing your JIMU robots?
Yeah, definitely. I always ask, what I want to do with the robot? What kind of task this robot will do to help, kids have fun? And then I always think about what does human do and what do we want our robot do? Like human, we pick up things, we throw things, we jump around. So if a robot can do all these 3, that's awesome.
Yeah, cool.
Yeah, that's the JIMU approach that I have. Yep.
Yeah. Okay, awesome. So now, guys, this is for all you guys at home listening. So we want for you to start your planning process. So we put 3 different questions on the screen. We're going to give you just around 3 minutes or so for you guys to brainstorm with your groups. If you're at home with your siblings or your parents or your guardians, we want you to try to answer these 3 questions at least. You guys don't have to stop there. You can keep keep coming up with answers and, thinking through what you want to do. But try to at least answer these 3 questions in the next 3 minutes. So question 1, what is your robot going to do? That's a big question, right? Question 2, how is your robot going to work? And then question 3, what is your robot going to look like? So we're going to give you guys 3 minutes. But if you don't finish, all of these answers, that's okay. You guys will have a lot more time. You can keep doing that. But I'm going to, be quiet now. And I'm going to put 3 minutes on the clock. So without further ado, I'm going to say go. Yeah, go guys. And now's a good time if you guys want to chat some questions into the chat box or into the Q&A box. Robert and I can answer some questions, but we want you guys to talk at home amongst yourselves. So we'll try to be a little bit quiet for the next 3 minutes.
The airport assist robot. It's pretty cool.
Oh,
I'm just in the chat room. Yeah.
Yeah.
Yeah, so the first question, what will we do, is basically you can let your imagination run wild what you want your robot to do. And second is basically it kind of grounds you a little bit. How are you going to make your robot work, right? So you can make a robot that can hover without any magnetic field. Okay, is that doable? Maybe not, because you don't know how to make it work. So that's the process. First, go wild. Second, think about how to execute.
Mm-hmm. And guys, we just have just about 1 more minute. I know that those 2 minutes went by really quickly. Oh, and it looks like Bernard has a really cool idea. So it'll work like a drone setup, much like 5 miles ahead at the airport as a security deck. So that's super cool.
That's cool.
Okay, great, guys. So once again, this was just a quick intro into your brainstorming planning process. It does not have to stop and live here. We encourage you after this, webinar to keep talking, keep thinking about how you're going to develop your robot, and keep that brainstorming going. Great. So after you have created a nice plan, this is the 3rd step of the robot design process. So this is when you really start putting all those pieces together and you start creating and you start building your robot. So Robert, I know you put in some images of something that you helped create. Do you want to kind of highlight how you go about creating and building your robot?
Yeah, definitely. So on the ground on the left side, you'll be able to see what I think a delivery robot in a hospital could look like. So you can see there's a flat surface. You'll be able to put like food or beverages on top. and this robot will deliver these food and beverages to the patients. And it drives just like a car. It has 4 wheels. The first 2 turn. So it's very the structure is pretty much very tested because it's basically a car. And then for this robot to work, how it's working. So to start, it will start at either the kitchen or a nursing station. Like a human will be able to put, let's say, put like lunch on top of the robot. And then this robot will be able to deliver lunch to said patient, let's say Tom, bed number 5. So the nurse will say, okay, cool, let's deliver Tom his lunch. So the nurses will say, okay, go find Tom. And then robot will start driving, and the robot will remember what the internal layout of the hospital, like how to get to Tom, basically. So you'll map out like the whole floor previously, and then during the journey, the robot will have different sensors around it, maybe 6 or more sonar to prevent the robot to, bump into other robots. And upon robot's arrival, robot will say, let's make sure I bring lunch to the right person. So the robot will have a camera in front of it to make sure, beep, 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 beep. Okay, this is indeed Tom. And then the robot will drive up to the bed. And then so Tom has access to his lunch.
Super cool, Robert. So as you can see, Robert drew this really cool drawing, this prototype of what he can build. And so you can see, this meets the criteria that we're looking for. So this robot would help, interact in between patients and doctors. For this case, it would help, deliver, different, kitchen items, meals, snacks, beverages, to the, to. Hello, everybody. So it looks like we got kicked out of our meeting. So, that's technology for you. But we really appreciate you guys joining. And let me see, it looks like a lot of people joined back on. So that's great. So I'm going to bring Robert back into the conversation here. Whoops. So I hope you guys, hey, Robert, can you hear us?
Yes, I can.
Okay, great. So super sorry about that, guys. It looks like we got, kicked out of our meeting, but that's technology, right? That's what we have to deal with, working at home. But we want to just kind of, wrap up real quickly and let you guys know that you don't have to finish your projects right now. Your date to submit all your projects is April 10th. And the way that you do that is you take a picture or post a video of your project, and label all of those robot, creation parts, and then post it to social media. So you guys can tag, our social handles, UBTECH EDU, at UBTECH EDU or hashtag UBTECH EDU. And you guys will be entered into a chance to win a super special prize, which is super exciting. So great. I know, sorry we had that hiccup. Apologize for that, moving on, but there you go. So I hope you really enjoyed this session. And you definitely check back, for future webinars, and keep following us. And we hope to see all you future inventors in the near future. So thanks again, Robert. I really appreciate you coming on.
Of course.
And great. Yeah. So hope everybody has a great rest of their day, and we'll be talking soon.